Hello everyone, welcome to Study Nurture channel. Today in our video we will discuss about the working of condensers. Before starting the video I want to say this, the condensers in our video we are going to discuss are based on the context of refrigeration systems. So let's start the introduction part. Condenser is an important device used in the high pressure side of the refrigeration system. So as we know that in our refrigeration system, we have compressor, we have condenser, expansion device and evaporator. So the condenser is the very important device that is used at the high pressure side. Means after compression, when the temperature and pressure of the vapor refrigerant increases, we use the condenser. Its function is to remove heat of the hot vapor refrigerant discharged from the compressor. The hot vapor refrigerant consists of heat absorbed by the evaporator and the heat of the compression added by the mechanical energy of the compressor motor. So the vapor gets its heat from the evaporator and the mechanical energy of the compressor motor also adds heat into the vapors. So the condenser removes this heat. The heat from the hot vapor refrigerant in a condenser is removed first by transferring it to the walls of the condenser tubes and then from the tubes to the condensing or cooling medium. Means the vapor first comes in contact with the walls of the condenser tubes, loses some heat, and then after that we can use water or air to cool the vapor refrigerant. The cooling medium may be air or water or a combination of two. The selection of the condenser depends upon the capacity of the refrigerating system, the type of the refrigerant used, and the type of cooling medium available. So this is the schematic diagram of simple refrigerating system. So we can discuss this diagram. So here we have compressor. You can see at first point there is a suction line. This is the low pressure side. The low pressure and low temperature vapor refrigerant from the evaporator enters into the compressor through the suction line at point 1. So here on the side of the evaporator we can say this is a low pressure side. So from the suction line the low pressure and low temperature vapor refrigerant enters into the compressor. The compressor compresses the refrigerant vapors and increases its pressure and temperature. This high pressure and high temperature vapor refrigerant goes into the discharge line and comes into the condenser coils. So these are the condenser coils, and in the condenser coils we can use air or water to cool the vapor refrigerant. So after cooling, the vapor refrigerant loses its latent heat and then it gets converted into the liquid refrigerant. The liquid refrigerant enters into the receiver. From the receiver, it goes into the expansion valve where its pressure and temperature are decreased. Liquid refrigerant goes into the evaporator where it gains its latent heat and the liquid refrigerant gets converted into the vapors. And then it enters into the compressors and again the cycle goes on. This is the pressure and enthalpy diagram for the refrigerating system. From 1 to 2 we can see that there is a compression. The pressure and temperature of the refrigerant increases from 1 to 2 in the compression process. And then there is a desuperheating process. The desuperheating process, the superheated vapor comes into the state of saturated vapor from 2 to 3. This process is called desuperheating. From 3 to 4, there is condensation, means the vapor refrigerant, the saturated vapor refrigerant gets converted into saturated liquid refrigerant. And then there is 4 to 5, that is subcooling. The temperature of the saturated liquid refrigerant again decreased to the point 5 so that we can increase the refrigerating effect. Then from 5 to 6 there is an expansion process. That means we decrease the temperature and pressure of the refrigerant. This liquid refrigerant at low pressure and low temperature goes into the evaporator and the evaporation takes place, means the vapor form of the refrigerant becomes at point 1 and then the again compression process will start. So the compressor draws in the superheated vapor refrigerant that contains the heat it absorbed in the evaporator. The compressor adds more heat to the superheated vapor. This highly superheated vapor from the compressor is pumped to the condenser through the discharge line. The condenser cools the refrigerant in following three stages as we have discussed. First of all, the superheated vapor is cooled to the saturation temperature called desuperheating, corresponding to the pressure of the refrigerant, as shown by line 2 to 3. So we have discussed that this line 2 to 3 represents desuperheating. The desuperheating occurs in the discharge line and in the first few coils of the condenser. Now the saturated vapor refrigerant gives up its latent heat and is condensed to a saturated liquid refrigerant. This process is called condensation, shown by line 3 to 4. The temperature of the liquid refrigerant is reduced below its saturation temperature, that is subcooling, in order to increase the refrigeration effect as shown by process 4 to 5. So here we can see from 2 to 3 there is desuperheating, from 3 to 4 there is condensation, and from 4 to 5 there is subcooling to increase the refrigeration effect. Now, after discussing the working of the condensers, let's discuss the factors affecting the condenser capacity. The condenser capacity is the ability of the condenser to transfer heat from low vapor refrigerant to the condensing medium. The heat transfer capacity of a condenser depends upon following factors. First one is material. As we know that different materials have different ability of heat transfer, therefore size of the condenser of a given capacity can be varied by selecting right material. It may be noted that higher the ability of the material to transfer heat, smaller will be the size of the condenser. Amount of contact. The condenser capacity may be varied by controlling the amount of contact between condenser surface and condensing medium. This can be done by varying the surface area of the condenser and the rate of flow of the condensing medium over the condensing surface. Temperature difference. The heat transfer capacity of a condenser greatly depends upon temperature difference between condensing medium and vapor refrigerant. As the temperature difference increases, the heat transfer rate increases and therefore the condenser capacity increases. Generally, this temperature difference cannot be controlled, but when temperature difference becomes so great that it becomes a problem, devices are available that will change the amount of condensing surface and airflow rate to control condenser capacity. So finally, most air-cooled condensers are designed to operate with a temperature difference of 14 degrees C. So that's all about condenser working and factors affecting the condenser capacity. Hope you like the videos. Like, share, and subscribe the channel Study Nurture. And for more knowledgeable videos, stay tuned. Thank you very much.